Alrighty, so I've had a couple of questions regarding Wireshark, and I decided to wait just a little bit on this video. I've learned that I think people learn more when they work through problems and then maybe get some of the details. And so hopefully everybody's either finished their lab or working on their lab, and this maybe fills in a couple of the holes. I'm going to have some other videos on Wireshark because I really think this is like one of the key uh, tools that, as far as investigating network security, troubleshooting networks, and just understanding how networks works. Um, you know, it's free. You can download it onto your personal machine and fire it up. And I'm probably going to have a using it on your own machine video here. So I highly recommend that you download it onto your machine and kind of get used to using it. So there's not a bunch of labs in this class, but it really is worth your time. So anyway, I call this Theory Meets Real Life because Wireshark is based on some of the theoretical stuff that you have learned in your networking class, the way they structure it. So it's really pretty cool that way. So anyway, so what is Wireshark? Well, Wireshark is a program that captures and decodes packets on a number of layer 1 protocols. Ethernet is the one that is probably the first thing that comes to mind, like your network interface card. It'll also do wireless data streams. So if you've got Wi-Fi, it acts just like a just like a NIC. It has protocol decodes. So there are specialty protocols out there like voice over IP and session initiation protocol. And when you're installing it, there's an optional thing where you can select USB. And if you're a security person, enable that, because there are a lot of things that can happen over your USB port, because it's a HID port, human interface device port. And so there's a lot of nefarious things that you can do over the USB port, and being able to look at packets on that is really interesting. So like I said, it's network troubleshooting, it's network intrusion analysis, and it's just basically understanding how networks work. So when you open up Wireshark, it has 3 panes, and which we see right there. Now I happen to have opened up on this is a screenshot of a file, IPv6 to CNN, and here you see the three planes on it. So the first plane is the packet list plane, and when you do a capture or when you play back a captured file, this lists all of the packets in order that they were captured. And so you can see that we have just a plain a sequence number, a timestamp, source and destination IP address, the type of protocol, how long the packet is, and some real basic decode info to give you an idea of what's going on with that packet. These columns are customizable. Time especially, right now this is just like relative time, but you can do time in between frames that are or packets that are received, and lots of different things. Standard time, especially if you have like a network time protocol server that you're connected to, so that you have real synchronized time. And like I said, this is just the number of the packets. When you start doing other things like filtering, seeing where the packets are in relation to each other, the number comes in handy. So anyway, that's a packet list plane. The next one down is the packet details plane, and as you highlight a packet, like here on the packet list plane, then the packet detail plane gives you the basic elements of it. And we'll see this at the end, but these correspond pretty roughly to some of the layers of the 7-layer OSI model, which is why the way they have this laid out is so cool, and why it really is a good learning tool. But you just click on the arrow, turn it into a down arrow, and then it expands the information. For example, this is a DNS response, the packet that I happen to highlight, and it shows you the flags, it shows you the whether it's authoritative or not. I mean, these are all you have to. One interesting thing, or one thing about packet analysis is if you don't understand the protocols, you're not going to be able to use this tool. So a good understanding of not only the OSI model, but also what are going on with all of the different protocols is pretty essential. And anything that is in brackets and highlighted as a link, and you can click on this and it moves on to it'll open up a window to give you additional information. And finally, we have the packet bytes plane, and this is essentially a hex dump here of the entire frame of the so this is the hex dump, and this is the ASCII decode. And so if it is a printable ASCII character, it will print it. So like moviecontrol.netflix.com, you can see here that this is text that was going out to the whatever the browser, whatever the request was. If it's a non-printable character, it just shows dots. So anyway, those are the three planes, and you interact with one plane, and it changes the other plane, and so the whole thing is responsive to what it is that you want to do. So. And this I guess is the going along with lab 1. The most powerful thing, besides the fact that it can decode packets, is the application of filters. So when you, especially anymore when we've got 10 gigabit interfaces on our routers, you have huge amounts of data potentially that you're capturing, and so filters allow you to reduce the amount of data so that you can get your arms around it and actually do analysis. So there's two kinds of filters. There's capture filters and display filters. And you're familiar with capture filters. You might not be exactly aware of that, but you actually set that up in the lab. Capture filters are set up before you begin capturing anything. They have less flexibility than the other kind of filters, than the display filters, but their role is to limit the amount of information that is actually captured by Wireshark. And if you've got a huge amount of information flowing on a port you're monitoring, you can easily overrun buffers, or you can just have so much information to wade through that even moving around in Wireshark gets to be slow because you have so many packets. And so you apply a filter, a capture filter, and then when you go to start capturing frames, that filter will act on every frame coming in and do whatever you've told it to do. Now, I say it's usually applied after analysis with the display filter, and we'll talk display filter in a second. The reason is that usually if you're starting an investigation, you don't really know what you don't want to see. You're using Wireshark to kind of dial in on the problem that you might be trying to troubleshoot, or the attack that you're trying to isolate. And so usually you will do a packet capture with no capture filters on, go into Wireshark, start moving through, start using the display filter, and then you can decide if it's appropriate then to go back and recapture with some filters in place to get a better set of data. So why in our lab did we start out and set a capture filter on our startup to no port 3389? I'm sure you all asked yourself that question, right? And you could pause here and think about it, or I guess I'll just tell you. 3389 is the remote desktop port, and if you remember when you did the lab, you RDP'd in, and so that would have generated a lot of extraneous traffic, and so they basically were filtering it out of the capture that you were doing. So and this is actually what you saw at the startup, right? You saw this is where you applied well, that says display. oh, here, I have this display filter and the capture filter. Confused myself there for a second. The display filter is part of actually Wireshark. The capture filter is down in this area, and when you fire up Wireshark the first time, this is what you see. So the two things that are obvious here are, number one is it lists all of your network adapters, and if there's activity on it, you will see little bumps, and if there's no activity on it, you'll see flat lines. And you can see I have a VM player on my machine here, and so it sets up virtual adapters, and that's what these guys are right here. I also enable the USB capture on mine, and that's here. But the local area network here, Ethernet, that's the port that I captured. And then up here is the capture filter, and this is where you told it not to display any of the 3389 traffic. So our capture filter is here, and the display filter is here. And we'll go to another way you can get to capture filters is once you got Wireshark running, is you just go up to the top menu and say capture options, and it essentially brings up a little more detailed version of what you see at when you fire the machine up. It gives you your the interfaces, and then down here it lets you set up the capture filter. And you have to have this checked. Promiscuous mode allows the your interface card. Remember, your interface card really, it's operating on layer 2. It only responds to anything to its MAC address normally, and so promiscuous mode says forget your MAC address, I want you to intercept every frame that is headed your way. So that's why that has to be checked. And so then the display filter, okay, so like I said, once you captured and then you stop the capture, you then use the display filter to start narrowing down the search. And we're going to have one entire quick video on display filters, because getting to know, understanding how to use this is key to being able to use this program. Now the key here is the fact that your capture data is in a buffer, and when you apply a filter, you get a view of the filtered data, but you never destroy the captured data. So you can always then remove your filter, you get your original entire capture file back, and then you can display and apply another filter and look at it another way. You also can save off the if you come up with a filtered capture that has all the information you want, you can save that off as a file, as a PCAP file, and then bring that up later with, that's just that sub portion of it. So lots of flexibility, and like I said, this is a video all on its own, so we will do that in a later thing here. You basically, when I guess continuing on the overview though, your filter is pretty flexible. You can filter by protocols like DNS or IP or TCP or things like that. You can just whether or not a field even exists, whether a flag exists in a field, text values of fields. You can compare fields. You can, I mean, the list just kind of goes on and on and on. And there's an expression builder here that allows you to start creating your filter by going through various selections, and after a while you get good enough that the ones that you tend to use, you just type them out directly. You also can set it up so that you can set up a capture filter so that when you can have it just sitting there waiting for watching traffic and not capturing data until a specific set of filter requirements come through, and then it'll start capturing, and then you can say capture a certain amount of data and stop so you don't overrun your buffers. So anyway, like I said, I mean, amazingly flexible here, and which also makes it somewhat complicated. And speaking of complications, I said this before, the value of this thing is absolutely proportional to how much knowledge, how well you understand network structure and network protocols. Now the cool thing is that you can use this to increase your knowledge of those things, which then increases the knowledge of Wireshark, and it's a real circular thing, and so anyway, very valuable tool. Now I said that if you remember the OSI model, which I have at the end in case you don't remember it, the bits come in, they're layer 1. The first thing that is there is the frame, layer 2. It's layer 2, especially because you have MAC addresses here, which are a layer 2 thing, and then you've got this payload here. And you have to have the preamble so that the hardware understands how to synchronize, and then the CRC to make sure that you don't have any corruption of the packet. But this payload, so what goes in the payload? Well, this is where the IP packet goes in. So as these bits come in, they come in layer 1 as bits. They are assembled as a frame in layer 2, and then they're taken up, and the IP packet, layer 3, is actually the payload of it. And so and I'm sure you all remember and memorized what the IP packet looks like. But this is the payload information here. This is in the payload there, and then it moves on up the OSI stack. And like I said, so here is a the details plane, but I have collapsed all of the fields, and if you go top to bottom is actually bottom to top on the protocol stack, which is here. And so this is we have the frame is coming in, so this is the wire. It tells how many bits came in, how many were captured, and so these numbers need to match. If they don't match, that means that you have a problem with the computer, probably that you're using. The data is moving faster than the computer. So if you think that frames look a little wacky or you're missing something, you check the bits. You check layer 1. And then we move on to layer 2, and here we have the MAC addresses. One of the things that you can tell Wireshark to do is to turn on the MAC decode. And if you remember, with the first part of the MAC address is dedicated to certain manufacturers, and so here we can see the source is Hewlett-Packard, and the destination is a Brocade, which is a router. Then we have the IP and version 4. So we know it's IPv4 that we're looking at. We know it's IP because we have source and destination IP addresses. Those are v4 addresses. We move on to the next layer. Layer 4 is where TCP and UDP live, and you can see we have the ports listed right off. So these expand into much more detail, but you can see that in the in this plane, they give you like enough information that you have a pretty good idea of what's going on and where you need to go. And lastly, on layer 6, we have where encryption takes place, and this frame happens to use TLS. So it's it was browsing to a web page that was HTTPS, and so we have transport layer security on here too. So this really explains it to you, just like the OSI model that we all know and love, going from the physical layer to the application layer. So anyway, that is the quick, maybe not so quick, but the overview of Wireshark. And like I said, I just really, really recommend everybody download it, install it on their machine, and just start playing with it. It's a completely invaluable tool, and employers are impressed if you if you know how to operate it too. So okay, that's all. Thank you much.